Right, so with that, let's move further. Right. Now, a question that might come to your mind is, why would you need an in-memory OLTP, right? So, just to let you know that, the in-memory OLTP was formerly also known as Hackathon. This code named Hackathon was arrived from a Greek word, right, for the numeric value 100, because it actually represented the Microsoft's goal of improving performance by up to 100 times, right? So that's how it got its code name as Hackathon. Now, in traditional SQL Server database engine, right? So if you talk about, let's say, be it SQL Server 2005, 2008, 2008 R2, 2012, whatever, right? So, in all the previous versions of SQL, right, the database engine was originally designed at a time when it could be assumed that the main memory was very expensive, right? It's still very expensive, but not compared to the way it used to be, in early 2000 days. So because of this, the data needed to be residing on the disk, right, except when it was actually needed for processing, right? So what I mean to say is that your data was residing on the hard drive, and whenever there were queries that kind of needed to read that data got loaded into your memory, right? So that was the architecture that SQL Server has been following till now. Now, this assumption is no longer valid because the memory prices have dropped enormously over the last 30 years, right? And at the same time, there are multi-core servers which are now becoming more affordable, right? And if I were to give you an example, you can actually go ahead and buy a server with about 32 cores and about 1 terabytes of memory for somewhere under 50,000 US dollars, right? So which is pretty cheap now. Now, the lock-free design that the in-memory OLTP feature offers is one of the key points that differentiates this particular feature from the rest of the database engine, right? Also, to let you know, it uses a new optimistic multi-version concurrency control mechanism in conjunction with algorithms that have been optimized for memory resident data. So we are going to talk a little more about this in the future slides, but in this particular slide, I'm just kind of giving you a glimpse as to what it is all about. Also, there is something called as natively compiled stored procedures. So the best execution performance, if you have to obtain the best execution performance, that is obtained when you use these natively compiled stored procedures with these memory optimized tables. So there is a demo lined up as well. So when we jump onto the demo, I think things would be more clearer to you, right? And these natively compiled stored procedures are actually stored as DLLs, which contain the machine code, and that's the reason you get even better performance every time you use them. All right. Let's move to the next slide. Now, before we jump on to the Microsoft's in-memory engineering design points, on this deck, let's take a look at a couple of key trends that have impacted our design. Now, as I said, one of course is the significant drop in the memory pricing that makes the in-memory databases feasible for customers. And the second is definitely around CPU performance flattening out, right? And when I say that, what I mean is that just throwing more compute power at a problem may not resolve the performance bottlenecks of your SQL Server, right? So with Microsoft, the in-memory OLTP, we have taken into account as to how do we go about better utilizing the existing CPU capacity that we might have at the servers, right? And yeah, so that's what predominantly what we're using it, right? Let's move to the next deck. Now,